We've got a great lineup of speakers here for you today, and we're really excited to present them. We'll get going right away. We're going to start with BIM 101 with Will Myers. He's a digital school instructor. He's an Autodesk Certified Instructor. He's also the development manager for Global eTraining, and he's got a lot to tell us about BIM and where it's come from and where it is right now. So we'll hand it right over to Will.
Hi everybody, can you hear me all right?
Yeah.
Awesome. Thank you all for coming to this event, and thank you Brady for that really creative introduction. So what I'm here to do today is really introduce the concept of BIM. Most of us in the collection of AEC industries, architecture, engineering, or construction really have a firm grasp on what BIM already means to design content, workflow, management, model ownership, and things along those lines. However, there are still a number of sectors and a number of areas within each of those sectors where this information can still be passed along and where it's still relevant to introduce this as an introduction, or to introduce people to the concept of BIM. So this is where this presentation comes in. So this is BIM 101, and this is preparing our digital school students for tomorrow's workplace, which is actually today. What's that now? Oh, okay. So a little bit of background about myself. I was actually a digital school student looking to get out of coveralls, so I decided to use my creativity, put it to use. I always liked drawing, I always liked design, so I went to digital school for the one-year engineering program with a process piping specialization. Over the course of that year, I became fluent in Revit Architecture, Inventor, and AutoCAD. And over the course of the subsequent years, have become professionally certified in all three. As an augment to that, my professional certification enabled me to become an instructor at digital school, and my expertise with the Autodesk software enabled me to start developing for Global eTraining. I'm now the course development manager of Global eTraining, and I'm now an Autodesk Certified Instructor for AutoCAD, Revit Architecture, and Inventor. So what is BIM? And that's what we're here to talk about today. So just as CAD, or computer-aided design, revolutionized drafting or design in the square and slide rule era, BIM is set to, or already has, revolutionized CAD. While BIM is now nearly ubiquitous in many industries, as I mentioned previously, there still is need to bring people into an introductory level of BIM, and that's why I'm here today. Especially as it relates to digital school, where we have a responsibility to not only teach our students CAD software to bring them into the world of CAD, but to help them understand how that BIM software, or the next level or next generation of CAD software, will enable them to step into their place in the future of design. So today we're going to talk about exactly what BIM is. We're going to discuss a little bit of BIM terminology, some words, some catchphrases, some ideas. We're going to spend a little bit of time talking about some perceived challenges or roadblocks with the implementation of BIM that may have been or may have been perceived to have been experienced as implementation happened. And then we're going to talk about BIM project benefits for a number of different stakeholders. So the first question is on everybody's mind by now, just what is BIM? And we can think of BIM as two distinct acronyms, although one is more appropriate than the other. They both make sense. One is building information modeling, and the other is building information management. And in many ways, they're both entirely accurate. So BIM is a process involving the generation and management of the physical and functional characteristics of a model, using a bringing those characteristics into a digital representation. Now, as opposed to regular 3D CAD or even 2D CAD, we deal with the concept of an intelligent model, an intelligent central model. And so any views, whether they be plan views or section views, elevation views, detail views, even tabular views such as schedules or quantity takeoffs, are all interrogations of this central model. The benefit of that is that if an element or some aspect of the model changes in one view, because it's an interrogation of the central view, all of those views update as a result, including the tabular views, which has great benefits for the management of a BIM model and the documentation thereof. So the resulting models become shared knowledge resources that support the decision-making throughout the design process, from the concept to design build, and then all the way through the operational life and eventual end of the project. So we know of BIM as building information modeling or building information management. The word came up, was the acronym, is somewhat proprietary, although it's being recognized throughout the collection of software design industries. But there are other names that we can use to describe what BIM is. Those would be the concept of a virtual building or integrated project delivery. We can talk about virtual design to construction. And each of these have the same idea, where we are looking at an intelligent model, which is a representation of a project that is yet to be developed, or in the process of being developed, or already developed and being managed. We also think of BIM as being mainly architectural, possibly because of the fact that we discuss a building, or there's some aspect of a building in this intelligent information model. But the fact is that a number of sectors that use intelligent design software are using the same concept, just with different names. So if we talk about geospatial industries, or surveying, or civil engineering, we talk about graphical information systems, or GIS. If we're looking at ongoing plant or product management, lifecycle management, we could be discussing facility information management. And more appropriately, we could consider all of these things to be asset information management or asset information modeling. In either case, we're modeling information into, or we're building information into a model so that it can be collaborated and used between all party stakeholders. The main key word here is information. And that with BIM, the information is collated, modeled, and managed, all with an understanding and all with the expectation of gaining more information from this intelligent model. So, what does BIM make easier? We talk about BIM making things easier for the collection of AEC industries, or for trade contractors, or for suppliers, or for designers. Well, let's consider what a 3D model is. It certainly helps the visualization of a project, because we have a 3D model to look at. The ability to create a 3D model also helps 3D coordination. So if we're discussing the idea of bringing an architectural model in with a structural model, in with a HVAC model, in with an electrical or plumbing model, and combining that with a fire protection model, or adding a landmass, each of these models that come together enable the coordination of the central model. And that'll, of course, help with the concept of clash detection. A great concept, or a great added benefit that's come out of having a central model that's already been fully detailed and is fully aware and intelligent of what its capabilities, what its cost, what its phasing is that you're able to prefabricate material. I recently attended a conference where I heard a story of a hospital being built where entire cells of washrooms were prefabricated and installed before the walls even came up. The reason for that is because they knew how many sinks they need, how many outlets they needed, what lengths of pipe they needed, and they were able to install these cells as soon as the structural support was there. The other aspect of that was the safety and health and environmental concerns, because all of these welding and machine shops were brought inside, and the level of safety and efficiency was gained as a result. We also have the idea of analysis. So what kind of analysis can we do on a central BIM model? Well, we can do cost analysis, solar analysis, or temperature analysis. We can do stress analysis. And all of these things can be undertaken based on built-in physical conventions that we already are aware of. The amount of time it costs to pour a square foot of concrete, what the temperature is in Edmonton in July, on average. And all of these and the central model can be analyzed against all of those numbers. Of course, we have the aspect of cost estimation. And finally, project phasing. We can determine exactly when a project is going to be complete, or what phase of the project is going to be complete, or at what time and at what cost. So when we speak of BIM, we speak of a generally recognized set of dimensions. And we, of course, know that 2D CAD is drawing lines and arcs on a page. And, of course, 3D CAD is the element of bringing those two-dimensional drawings up into an x-axis or into a third dimension. When we discuss BIM dimensionally, we actually can add a couple of other dimensions. This gets a little bit nebulous as we get closer to the sixth dimension. But when we add the generally accepted fourth dimension of time, we are actually making a model that we can see how it's going to behave over time, over the course of a year, or over the course of a decade. We can add another dimension, the dimension of cost. So when we look at a central BIM model, we can determine how much it's going to cost over how much time. And finally, we get into the idea of building lifecycle management or project lifecycle management, where we can manage cost over time of several models that are all involved in the same project. Now, just as there's dimensions for BIM, there's also levels of BIM. And you can see our first level is level 0. And that's just simple 2D CAD. And we won't even need to really discuss that because, well, we're not here to discuss 2D CAD. We're here to discuss 3D BIM or multi-dimensional BIM. But you can see the overlap between the two where CAD, workflow, and software stops at level 1 and interchanges with level 1 BIM. And then we can see BIM software and workflow expand as we go into the higher levels. So let's discuss some of those higher levels. When we talk about level 1 CAD or BIM, we're talking about simple 3D CAD. So this is a concept where a modeler or a designer is using a possibly brand new piece of design software simply as a modeling software. It's simply 3D modeling. There's no intelligent metadata put into the parts. The elements don't know how much they weigh. They don't know what they cost. They don't know how warm they'll be. They don't know what their draft angle will be. And none of the coordination or virtualization or phasing or scheduling elements that are built into the software are used. We're simply looking at a 3D model. We're taking the information out of the BIM and we're just left with a building model. So as we become more and more familiar with the capabilities of our software, then we start to expand into level 2 BIM. This is also known as siloed BIM or little BIM because these software capabilities are now starting to be recognized as far as the virtualization, as far as some of the other aspects. But the documentation, the sharing of that information is still very much in a silo. It's still very much individualized. And traditional methods of communicating, such as scrolls and scrolls of shop documents, or filing cabinets upon filing cabinets of plans are still implemented, used, and depended on. When we talk about level 3 BIM, this is where I believe that most industries actually are within Alberta and globally. However, there are still areas of gray or areas where catch-up can occur. But this collaborative or big BIM or IBIM, meaning intelligent BIM, is where the industry or the collection of AEC industries aspires to belong. In this case, the software is used fully functionally as a 3D model for interrogation or for analysis, for virtualization and visualization. This concept of coordinating several models is utilized and made use of more and more. And the ability to analyze the model for temperature, for cost, for stress. All of these elements that are built into the model are now being used fully and functionally. So this brings up a concept of being software agnostic. Of course, Digital School is an Autodesk ATC, and so we deal strictly with Autodesk products. But as most professionals will tell you, they don't work in a strictly software faithful environment. Most companies will be software agnostic. However, the idea is that if you are a master of one software, it's really easy to sort of see the similarities between the two. And of course, the more technical understanding that we as Digital School designers have, the better. So one of the concepts of being able to really work with the central model is that the data is regularly shared in coordination meetings with all stakeholders. Frequent collaboration meetings empower the collation of all of this information, and that relates to all of the disciplines that are involved in a project. So the HVAC trade contractors can communicate with the structural contractors using clash detection and the coordination meetings. The plumbing trade contractor can be told that, well, the main water pipe is in the way of the structural beam, and so it has to move. And it's really easily done with the collaboration meetings. And this helps resolve clashes. So another concept when we deal with BIM is the concept of the level of detail involved in a building model. Of course, Rome wasn't built in a day, and neither are building models. And in fact, they can start quite simply as simple blocks, or blocks of clay on a design sheet. So level of detail or level of development can spell out the expectations of stakeholders in terms of granularity or detail. LOD is often linked to the time and stage of a project completion. As I mentioned, when you're doing strict massing analysis, well, you don't need to have all of your light fixtures fully articulated. There's just no need for it. As long as you know the volume and square footage or area of the location of the lot you're going to be on, a cube is fine. But as you get in further into the facility management, then the idea of having all of those elements fully articulated and intelligent comes into play. So there are a number of standards globally for the level of detail as they relate to a project. The one that may be more appropriate to us is the level of detail for the American Institute of Architects BIM standard. So we start, if you look at this graphic, we start with LOD 100, which is strictly a massing, which is strictly a mass. As you can see, it has no walls, it's strictly a space. It knows what its area is, it knows what its volume is, it knows what its general shape is going to be, but that's all it is, and that's all that's required for the time being. As we get into LOD2, we look at the white model, as we see in the middle here. And this is our white model as we would recognize in any presentation design as a white paper model, except in a digital form. As you can see, the elements of the building are more articulated, not to a high level of granularity, but enough so that a stakeholder knows exactly what they're getting for their money. We have LOD 300, where the generic elements are now replaced with data-rich elements. And this is where we get into the concept of adding intelligence to the model, where a pipe knows the force amounts or how much volume it's going to be putting out over the course of an hour, or an electrical socket, what its load-bearing capability is. When we get to LOD 400, now we start talking about additional design and industry-specific metadata. So we talk about exactly the type of pump that's going to go into the boiler room, or the type of boiler, and exactly what its cost is going to be. Probably even links to spreadsheets. And all of this information is built into the model. Finally, we get to LOD 500, which is at the very end, which is our as-built model, which allows us to know exactly what the time it's going to take to build it, what its cost is going to be, how warm the south end is going to be in December, things along those lines. So we've talked a little bit about the terminology of BIM, some of the words and ideas that relate to BIM on a very high level. And we'll just talk about very quickly about some roadblocks or perceived roadblocks that people face as they're implementing BIM in their workflow or their development of content. So one of the main ones is the time and cost it takes to switch to a new system or a new way of doing things. Another perceived challenge is a lack of industry standards relating to BIM content or workflow. And this is something that's developing as we go along, but some places more than others are slow to catch up. Although there are initiatives globally working to make this a reality, there are still some sectors that need work. Finally, or the idea of limited industry expertise when it comes to the undertaking or ongoing management of a BIM project. And finally, and possibly most importantly, is the proprietary aspect of things. And it's a huge question when you're dealing with millions or billions of dollars, is who owns that model? The final question is, why is all of this important? And the main question is money. As designers, as stakeholders of any type, everything is based on how much it's going to cost or how much time it's going to take. And so the efficiency that we can build into a central model and the intelligent gains that we can pull out of a central model equal savings of time, which equals savings of money. And nearly everybody loves to save time and money. So we'll sort of quantify this for a second. And this is one of those studies that I did a Google search on, went like that, and picked one, because there's hundreds of them out there. All of them say the same thing. This was a study undertaken by the Construction Research Council in Australia, and it was called Implications for Building on Government. And they suggested that from their study alone, that nearly 30% of costs were wasted in the construction industry over the course of a project. Well, where does that money go? Key barriers such as the lack of uniformity in documentation, particularly with standards, workflows, and schedules were noted. And coordination errors, incorrect material procurement, and labor inefficiencies are always the result. And as I mentioned, that's just one study in one part of the world. So what about Canada? What's Canada doing as far as its implementation or ongoing work in BIM? Well, as you can see, there are a number of BIM councils and organizations within Canada, and a number of documents and standards that have already been created. So Canada is one of the leaders globally in many industries as far as the development of BIM workflow. And eventually, federal mandate will state that all projects will need to be managed, collated, and undertaken with a central BIM model. The main reason being the time and the cost savings. So we're going to finish off with a little bit of benefits that have been found for a number of stakeholders. So for owners, managers, and developers, really the key is the savings of time and the quality of projects, and the lowering of cost risks. The ability to deliver a central model over common portfolios between all stakeholders is a benefit. And BIM allows the implementation of standardized asset and maintenance management and reporting. So ongoing project or lifecycle management is made easier by the ability to look at a central model. For head contractors, BIM documented projects are more likely to be constructible with, again, lower cost and time concerns, as well as quality. A lead contractor working on a BIM-enabled project will understand that documents will be standardized across the entire project. And this central model will be more easily used for scheduling, cost management, and sustainability. Trade contractors will find that a properly implemented BIM will reduce construction documentation costs. That pre-construction coordination and clash management means far less lost man hours or work hours in gaining or in getting a request for information. A simple example of this is if someone has poured a foundation of concrete and all of a sudden on the last pour you recognize that something doesn't line up by 30 centimeters. So you need to do a request for information to find out what the dimensions are or what the problem is. Using traditional methods, that could take a number of hours, that could take a number of days. I'm sure it's not unheard of for a request for information to take a week or more to get back to a designer or a trade contractor so that the understanding can be made as to where something went wrong. That costs time and it costs money. Finally, project phasing with BIM enables pre-construction with a high level of certainty. I mentioned previously the concept of adding entire washroom cells into a hospital before the drywall was even put in. For suppliers, BIM-managed projects provide highly accurate schedules and takeoffs. There's no overhead. You know exactly what you need to buy, you know exactly what you need to supply. Product lifecycle management can be tracked through either Element ID coding or COBie coding or even through electronic tracking. You can, suppliers can manage the life cycle of their own project or product within that project. And finally, BIM is the lowest cost means of engaging BIM-enabled IPG product delivery for projects. Finally, for designers, and this is where digital school comes in, because digital school is on the edge of providing these collection of industries with their highly trained and highly talented designers. The main concept is the ability to work with a number of different softwares at once. So if you know AutoCAD, that's great, because AutoCAD is ubiquitous. But what if you know AutoCAD and you can work with Navisworks, Inventor, any of the Revits? What if you can work in 3ds Max Design and do presentation quality chase, or a presentation, videos, animations? So the diversity of your software expertise and understanding will only be of benefit to you. Of course, there's the ability to contribute to the future with managed design content. None of these BIM projects are possible if a Grunfus pump, for example, or a General Electric bulb aren't perfectly modeled with the forces, costs, and all of the other information, the metadata that's inputted into that model that can be pulled out of the model. And that design content needs to be created, and it needs to be managed. Finally, designers will expect that clients will require projects to be BIM-enabled, modeled, and documented. So I'd like to thank you all for spending this several moments with me to discuss BIM 101, what it means to tomorrow's workforce, and what it means to digital school students. You'll hear this a number of times over the next couple of hours, but I would invite you all to come back to the Digital School Open House to take a look at our facilities, take a look at the programs that we offer and the software that we instruct, and take part in the future of BIM with Digital School. Thank you very much.
Thank you, Will. Will, if I can get you to keep your